Sketch the following factorized polynomial: x plus 1 times x minus 1 times x minus 2. We're moving on to sketching a different type of cubic graph, which we've mentioned earlier. The most basic type of cubic graph we've been able to draw using transformations looks like this, where there's just a point of inflection, and that's the only interesting thing about that curve. Now we're drawing graphs that look a bit more like this. There are a minimum and a maximum turning point, as well as there's still a point of inflection in between them, because the curvature changes. And the way we draw these graphs will be we won't be able to draw them by finding the point of inflection and then using transformations. We'll have to draw it by finding the x-intercepts and then figuring out the direction of the curve. So it can go that way, or it can also go the other way like that. Once we have the x-intercepts though, that's a really good place for us to be, and then after that we can draw the shape. So this is actually why we've done all those previous topics where we learned how to find the x values using the null factor law and by factorizing, because in the end we just wanted to be able to find the x-intercepts for us to draw cubic graphs. Let's give this one a go. So it says sketch this formula. So the way we will find the x-intercepts is we'll say let y equal to 0. So 0 is equal to x plus 1, x minus 1, x plus 2. Oh, x minus 2, my bad. So we're really lucky because this example is already fully factorized. So we can just go ahead with the null factor law and say x plus 1 equals to 0, x minus 1 equals to 0, or x minus 2 equals to 0. Rearranging each of these, we get x equals to minus 1, x equals to plus 1, or x equals to 2. And these are actually our x-intercepts. So we have minus 1, 0, 1, 0, and 2, 0. I'm going to go and put those straight ahead on our axes. So I'm going to make a pretty big scale. So minus 1, 0 will be here, minus 1, comma 0. Then I have 1, comma 0. And I also have 2, comma 0. Awesome. Now the question is, how does our graph go through these points? Does it go through like this? Or does it go the other way like this? The way we can figure that out is by finding one more point, which will be the y-axis intercept. So let's find the y-axis intercept. So let x equal to 0. So the y-intercept is equal to 0 plus 1, 0 minus 1, 0 minus 2. So that's equal to 1 times minus 1 times minus 2. And that all multiplied together is equal to positive 2. So our y-intercept is at 0, 2, which will be maybe here, 0, 2. And that tells us enough information that we can now draw our shape. We know it has to go up in between these two, so it must look something like this. It's going to go up and over, down here, under, and then away like that. All right, so that's it. That's how you draw a cubic. The point of inflection and the maximum and minimum turning points at this stage can't be labeled because you need to be able to use calculus to find them. So for most questions that you'll be doing at this stage, the questions will not expect you to label those points. However, in the future, you will learn how to use calculus to find those minimum and maximum turning points, and those you would also label once you're able to do that.